Okay, I'm just gonna introduce myself first. So, hi, my name is Teddy. I'm currently a PhD student at the University of Oxford. I'm doing PhD in physics, in quantum physics. So previously I was from NUS High. I got um I got the International Physics Olympiad gold medal and the Asian Physics Olympiad silver. And I was also in the math national team. Uh, Yeah. And I also did the Singapore Young Physicist Tournament and also SSEF, the project competition. And then after that, I did my undergraduate at Cambridge in Trinity College doing math for 4 years. Okay, so yeah, and I've been teaching Olympiad since like 2020. So I've taught I think quite a few batches, at least three or four batches of people who have, like went to do IPHO, and there are some of my students have got IPHO silver, and I think one of them has gold. I also have some students with APHO bronzes and silvers. Okay, so here's just a review of the competition schedule. So for physics in year 1 to 4, the first thing you will get, so time goes upwards in this graph. Uh, the first thing you'll get is the SJPO in May, and then SPHL in July. And then you can also do projects, so you can do projects anytime you want, but basically the cycle is that the SSEF is in March. It's Singapore Science and Engineering Festival. Um, so if you want me to speak about projects, you can ask me later at the end, but I will not say too much. Um, and for year 3 to 4 mainly, there is something called the Singapore Young Physicist Tournament, which is usually from September to January. And then this is also a project, but this project leads on to the International Young Physicist Tournament. Um, Yeah. So SSCF also leads to the International Science and Engineering Festival and a bunch of other project competitions as well. You can ask about that. And also there's astronomy, which I didn't do myself, but there is some astronomy competitions. And also, as you know, there are math competitions also. So from what you can see here, right, is basically the progress for doing physics Olympiad um is there's no rush. Basically, because nothing really happens until year 4. Like these competitions don't really lead you to anywhere. So in year 4, you will have SJPO, and the people with SJPO gold, I should probably write SJPO gold. Yeah, your school will send you for the European Physics Olympiad selection test in August, and this will be a different style of question to SJPO. Um, it'll be like a more European style. And 5 people will be selected to go for the European Physics Olympiad. And then in year 5, there's no more SJPO. There is SPHO, Singapore Physics Olympiad. Um, Basically, you have to be in the school team for this, which you should be if you have SJPO gold or silver, something like that. Yeah. So as after SPHO, if you're a silver and above or just top 30 in general, you'll get selected for the national team training. And then in March, you'll get the national team selection test, where the top 5 will go to the International Physics Olympiad. The next 8 will be Asian Physics Olympiad, and then the next 4 will be the International Nuclear Science Olympiad. So the international competitions matter more because you then apply to university with this thing on your resume, on your achievement list, and it matters more. Okay, so there's also SPHL. You can take SPHL anytime, but SPHL doesn't lead to anything, so I didn't include it here. Right. Somebody asked me to suggest some books. So I'll send the slides later and you can take a screenshot if you want. But basically, there are some books for general reading books for interest and also um introductory level books. So the first one that I was recommended was Colin Kauf, Introduction to Mechanics. And also at this stage, if you're year one to four, I would really say that you should focus on your you should focus on your math. One, because the math competitions are more relevant to at every year, every level, because there are more math competitions. And also because to do physics, you just need to do a lot of math. So you need to get good at uh, a lot of calculations. So after this is really a basic level book. There are much more difficult books. There is David Morin. There is um, there's like Griffiths and so on. And you can ask me if you need them. I think if you're year one, the school recommends you to buy the book called College Physics, which is the massive book. Um, in my opinion, this book is very slow and very too much talking and not enough information. So it's not really the best book to learn with. Yeah. Okay. So and then the classes that we have is on Saturday, 4:30 to 6:30 Singapore time, there is a IFO preparation class. So there are some, I'll have some lectures and then some basically preparing, doing past papers for SPHO, then the national team selection, then IPHO. For Saturday, 7:30 to 9:30, it's a SJPO class. So the ex current people in this class have learned all the topics for SJPO. And then now, next, what we're going to do is we're going to start learning calculus. And then we're going to learn all the topics again, but with calculus. And the reason for this is even though SJPO doesn't need calculus, SPHL needs a little bit of calculus, but it's really that the European Physics Olympiad selection test will need calculus, or you need to know a lot more stuff than the SJPO syllabus includes. Okay, that's what I have. Yeah, that is what I have. Okay, does anyone have any questions?
So the IPH class is between 4:30 to 6:30 Singapore time.
Yeah, hang on, let me share the screen again. Yeah, so the 4:30 to 6:30 is for people who are in year four, five, or like year four or JC1. And then this one is for people who are below that.
Got that. But IPHO one, you how many classes it will be?
Um, so so this is Saturdays. It will be out of 52 weeks, it will be around um 30 something weeks because it generally depends on my schedule, but usually
Okay.
we charge every 2 months. So every 8 weeks there will be between 5 to 6 lessons. Yeah.
So, okay, so it will have modern physics lecture plus SPHU preparation, NTST preparation, and IPHU preparation. Okay, okay, got it.
Yeah. And we'll be using questions from China, from Russia, like yeah, from other countries also. Thanks. Right. Okay. Any other questions? Um, Somebody asked for the books, right? Who asked for the books? Oh. Is that the only time slot available? As in it can move maybe forwards or backwards by half an hour. But it, that basically because I'm in the UK, so the overlap of the time zone means that that is basically the only bit of time that there's overlap. The first session of SJPL. So I'm planning to start the basically this course on July 12th, so next weekend. Yeah. There's no lesson this weekend because of SPHL. Okay, so if you have no questions, what I will do now is I will just pick a problem and then teach it so you can have a sense of uh I don't know how I talk and things like that. Um okay, so let me get a question. Sorry, just give me a minute. Right. Okay. How many students are in each class? On average, we have been having around 8 to 10 students in each class. I mean, it is the only class, so it is just how many people sign up after today. So, but that's usually the size. We need a minimum of 5 people to start the class, by the way. Okay. Right. So, uh, Can everyone see the screen? No, I lost. Okay, I lost control of this thing. Whoops. Ah, okay. Right. Okay, it should be bigger now. Will there be homework? Yes, there will be homework. But I mean, doing homework is kind of up up to you. If you do homework, I will mark it, but it's also um everything will be said in class. So if you like miss some homework, it will be fine as well. Obviously, the people who actually go on and get gold medals and so on are the people who do homework. And that's not a coincidence. Yeah. So if you want more work, I have endless amounts of more questions to give. Um, sorry, I was muted. Okay, sorry, can you hear me now? Okay, so this problem is from SPHL 2024. Okay, so I'm just gonna go through this problem um, as an example. Okay, you should be able to see the screen now. Yeah. Okay, so here we have a battery with 12 volts connected to two resistors and two resistors. This one is 20. Why is it not letting me write stuff? Oh, this one is 10. Um, and then we have an inductor and the switch has been open for a very long time. Now you close the switch and we want to find the voltage across the inductor at the instant after the switch is closed. So what is an inductor? An inductor is basically just a coil of wire. Okay. So the key thing about what an inductor does is that it basically stores energy in in terms of current because current produces magnetic field and magnetic field carry energy. So the current cannot suddenly change. Okay. And the formula for the inductor is that the voltage is L di dt. L is inductance. So implicit in this equation is that there is a di dt, meaning that it is differentiable. And if it is piecewise differentiable, assuming that it is piecewise differentiable and continuous. So when you close this switch, right? Uh, okay. Um, how about now? Okay. Sorry, I dropped out again. Everything okay now? So when you close this switch, right, you'll first get a um you'll get a voltage across here, but because of the fact that it was initially not doing anything, there must be initially no current. Okay? Um, which means that let me just draw this diagram again. Which means that the current is going to be basically just through here, the top one, and there'll be no current here. Okay, so because this is now a series circuit, what is the current? The current is simply the voltage divided by R1 plus R2. And what it also means is that the voltage across here is just this one is R2, right? So it's just R2, I times R2. Okay. So given that R2 is 10, R1 is 20, then it is just 1/3 of V. Let me call this V2. Right, so that is the voltage across this parallel bit, okay, which is the answer to A. So that's the answer to A. Okay. Um, of course that's 12. So the answer is 4. 4 volts. So the next part is after a long time, the switch is now open again. Find a new voltage the moment the switch is open. So what is a long time for the inductor? So after a long time, the assumption when people say after a long time is that there is no changes. There should be no changes. That means there should be a constant current and voltage. Okay. So what happens when there is no changes? Well, in a case where there's no changes, the derivative, the IDT is 0, so the voltage across the inductor is also 0. Okay? But if the voltage across the inductor is also 0, um, then the voltage across the resistor is also 0. So the resistor is not doing anything. So the resistor has no current. So what is really happening now is this. The current just goes through the bottom branch, and there's no current through the top branch. Right, and the voltage here is 0. So basically the voltage here in the first one is just the same as the battery. Okay? Right, so that is before we open the switch. So what happens right after we open the switch? So let me just write down there's some current here. So um, the current is just voltage is I times R1. Okay? Let's call it I1. So where is the switch? The switch is here. So if you open this switch, what will be the circuit now? If you open the switch, the circuit now will just be the inductor and the resistor, right? And what the inductor does, again, is that it makes sure that the current is not changed as you do something. So the current doesn't change suddenly. So the current here will still be I1, and I1 will now flow backwards through R2. So in other words, the voltage here will just be I1 times R2, which is um, R1 No, R2 over R1 times of this. Okay, I think that's what they want. Yeah, that's what they want. Right, so this is a very straightforward question. Basically, it just asks you to remember what does an inductor do. And an inductor follows this equation. The voltage is L times the rate of change of current, and also that it doesn't allow current to change to jump suddenly. Um, so just to for completion's sake, the integral version of this equation is phi equals to Li. So the magnetic flux is the current times the inductance. In fact, that is the definition of the inductance. When you differentiate this with Faraday's law, you get a voltage. Yeah. Okay, cool. Any questions about this? Um, so as you can tell, my Wi-Fi is not being very lucky today. Um, so apologies about that. Does anyone have any questions in general? So basically what happens is that every lesson, I will send some worksheets as homework, and then I will just basically have the problem and I will write the solutions like this, and I will send it to you afterwards. And everything is all this like document stuff is managed on Google Classroom, along with the recording of the video. So you can, if you miss the class, you can just watch the video. Yeah. Right. Okay. So since there are 16 people here, I'm just going to do a poll if I can. Um, yeah, I can show the books again. So these are really books for how do you say for beginners. Okay. You should have a poll popping up now. Yeah, so basically the uh for calculus, we're going to learn calculus. If you think you already know calculus, we can discuss that. If you're I think if you're year one or two and you don't feel like you're ready to learn calculus, then what's gonna happen is that next year the cycle will come around and then you can see what classes we have because we usually have two out of the three classes. So we have, I mean, there's year one to six, right? So year one and two will be the basic class, the beginner class, and then year three to four will be the advanced class, and then 4 to 5 will be the IPHO class. Um, but yeah, if you have any questions, don't hesitate to get in touch. Um, so I think you guys probably received this link from WeChat. So my mom on WeChat mainly handles all the administrative questions, so you can ask her about that kind of thing. How many classes overall? It's around, let me think, around 52 divided by 8. 6.5 times 6. Actually, it's around 4. Okay, so I guess it's around 35 to 40 per year. Um, yeah, as in for both of them. Because so basically every 2 months I will ask people for your schedules, and then obviously if there's some event happening that nobody can come, then there will not be lesson. And if I'm busy, also there will not be lesson. So on average, that's about the number of weekends per year. Yeah. Yeah, like including like, Christmas, Chinese New Year, uh that kind of that kind of thing where nobody would come to class. So yeah. Good. Any other questions? So I see most people are year three, which is a good time to start. So if you're interested, you should drop my mom a message on WeChat, and then the schedule and the fees will be sent out very shortly. Um, in December, usually there will only be 2 lessons or so because a lot of people are on holiday. Basically, I will ask like this day is how many people are on holiday, this day, how many people are on holiday, and then we just arrange it so that um, so most likely December there are very few lessons, basically. Yeah. Um, um, yeah. Can we go through? Um, yeah. Yeah, so I would say there's a yeah, I'm sorry, I don't know what's happening with the internet today, but usually it's better. Um, yeah. Yeah. So if you think you already know calculus, then also do mention that when you contact my mom on WeChat, and then we can arrange the schedule um, more specifically. Right. Any other questions? Which question did you want me to go through? Third one. Right. This this is actually a bit more of a geometry. Okay, so we have to end in about 15 minutes because I have another appointment later. Um, so I don't know if we have time to discuss this. Give me a minute. Um, right. Uh, okay, any other administrative questions before I do? Okay, well, I'll just say what I can say within the time. So we're looking at this question now. Uh, I actually have a bit more to say than 1 mark, but so this is from European Physics Olympiad uh this year. Yeah. Okay, so current flows through an infinite straight thin wire. There is an externally imposed uniform magnetic field directed parallel to the wire. So as maybe just a reminder, we have current in the wire, we have magnetic field according to the right-hand rule, right? So the right-hand rule is the thumb is the current, and then the fingers will give you the direction of the magnetic field, and the formula for that is mu naught I over 2 pi r as a function of the radius. And they also say that there is an external magnetic field parallel to the wire. So what happens if you add that, right? Basically, you just get, if something is going around in a circle and also going up, then you just, it just looks like a helix. So if I can try to draw it, um, it will be, a very flat helix from the outside. Oh, it's very hard to draw. And it will be a narrower helix on the inside. Um, no, it'll be a flatter. Sorry. So they're all gonna be helixes because they are a combination of a tangential part and an upwards part. Um, yeah. So this is what one of them looks like. Yeah. The inside one I'm drawing a different color, I suppose. The inside one will be more flat, something like this. Yeah. More flat but stronger. Okay. Right. Let me get the other question. So in my opinion, this is a bashing problem. Not sure what your opinion is. So here we have two infinite straight thin wires X and Y. They also have a diagram. Um, yeah, so okay, when we have lesson, right, these will all be prepared. It's just because today is like people are asking random questions, so I'm doing all the screenshotting. So here we have wires X and Y. They carry the current I as indicated, and they go in the X and the Y axis and passes through a point 0, 0, minus A. So that point is 0, 0, 0. This point is 0, 0, minus A. So it's A below the X wire. And P be a point 3A, 0, R. R is much less than A. Calculate D, the distance of the closest approach of the magnetic field line that passes through P to the y-axis. Okay, so obviously we can simply write down what the magnetic field is for um, any sort of like uh, thing. But then what does it mean like this line that passes through P to the y-axis, right? So what the question is trying to get you to think is that there's a you gotta think about this helix, right? And in the first part of the question, they said there's a uniform straight magnetic field. But of course here there is no uniform straight magnetic field. There's another wire, right? So if it's just the y-axis, then of course the magnetic field just goes around uh like this. Right? They are just loops. They are not even helixes. Okay? Um, so just X. So what about Y? If it's just Y, then what do you get? You get magnetic field which is like this. So I draw the one that goes through P. So let's say P is here. Yeah. So as you can see, there is basically a magnetic field sort of in this sort of way at P, right? And roughly like this. Okay. So what they're trying to get you to think is that they're trying to get you to assume that the magnetic field coming from Y, the red ones, is similar to the externally given magnetic field. Maybe I'll draw this with red to make it right. So qualitatively speaking, um, what is going to happen? So you see that um, this thing is like that's the x direction, right? And then the magnetic field produced by Y will have a component that is parallel to the wire in that direction. Okay? And also, of course, it's stronger here and weaker here. So what happens when it's weaker is that the helix is less sloped, and if it's stronger, then the helix is more sloped. So as in if you look at the stronger area now, um, something like this. So the strongest area will be this perpendicular line, right? The strongest area will have magnetic fields which look like this. Okay, so essentially the magnetic field at that point is parallel, roughly parallel, like this. And what that means is, and this is strong. Okay, strong. So strong means that the actual magnetic field, when you add in the, of course, circular magnetic field that the y-axis has, is going to be a strong um, helix thing. Okay? And what does strong mean? Strong means that magnetic field lines are close together, right? Okay. And so a similar logic applies over there, but of course it's weaker because it's further away and also the angle is not exactly 90 degrees. Um, so it gets weaker. So it's gonna be a helix there, but it's gonna be, let's say, a not close together helix. Um, yeah. Okay, does this all make sense so far? So I'm afraid we only have a few minutes left, so I won't be able to finish the question, but I just hope that this gives you a little bit of more intuition first. Uh, okay, so um, yeah. Okay, so what else is happening here? Well, they did say that they want the magnetic field line that passes through P to the y-axis. And normally, if it's just the y-axis, it would be like this one. But here, clearly, because there's a component of the magnetic field that's pointing in the x direction, that means that the there will be a part of the loop that looks like this, right? But what about the part like, but now you got to think about rewinding this, okay? So if you're rewinding this, then I hope you could imagine that if it's gonna get wider, um, as it goes out in the x direction, then the other direction will go narrower. Um, does that make sense? Yeah. So finally, the next ingredient that you need in this problem is that when people ask you about the magnetic field line, it's actually very um peop okay, so when people ask you about magnetic field line, people are not asking you about the magnetic field line. Magnetic field lines um are hard to get and not useful. Okay, so if people ask you to think about what the line is, they're not asking you to think about what the line. They're asking you to think about something else. So the main usefulness of the magnetic field line is that if because of the no magnetic monopole property, meaning that magnetic flux is always conserved, right? So what they're actually asking you to think is where is magnetic flux conserved? So if we have um, magnetic field lines that look like this, then what we can do is we can trace out like a kind of shape through which magnetic flux will be conserved. Okay, in the same way that, and this is a real your EUPHO problem. There was a problem with an airfoil, okay, right? And they draw you this thing of an airfoil, as you know. And then they ask you about to calculate something from this. And what are you supposed to do? You're supposed to say that each of these streamlines is going to carry the same amount of air going in and coming out. Okay, so this is exactly the same thing. The streamlines of air is also very difficult to obtain and not very useful. The only thing it really says is the conservation of the amount of air. Um, and it also says the same thing, which is that if it's closer together, it's faster, um, and wider apart is slower, things like that. But so when you're thinking of when people ask you to think of magnetic field lines, you also might want to think about fluid lines and conservation of fluid similar to conservation of magnetic flux. I forgot which problem from this is already, but it could possibly be iPhone 1991. I have to check. Right. So basically, the problem is trying to get you to think about the magnetic flux. And once you think about the magnetic flux, you no longer have to think about this loopy line thing. You just think about how much magnetic field is coming out of here, how much magnetic field is coming out of here. And if you want the smallest distance to the axis, you just want a smaller circle, means you want the biggest magnetic field. That's about it. Okay. Um, any questions? So I understand that probably most of you don't really know what I'm talking about because this is a higher level overview of the question. So the other thing I should say is that I also set problems for the national team selection, which means that I know the style of problems that I mean, not just me, but a bunch of people set the problems as a committee. So um, basically I know the style of problems that they will ask. And I know that like having set problems, I know like what is the overarching theme that that they want you to think about. Um, which is often the difference between like a good student and a really good student is that a a good student would do the pro like memorize all the formula, do the problem, fine. Um, but a really good student would know what the question setter really wants to say. And usually that leads you to like a faster solution. Okay, if you have no questions, then thank you very much for coming. Once again, you can contact my mom Alice on WeChat to ask more about the admin details. Yeah, thank you very much. See you soon, hopefully.